This is question 2 for probability and stochastic. And question 2 asks about, it is suggested that the following function of v, a is equal to Fourier f, capital F of v is equal to e to the power of minus absolute value of v, b is equal to capital F of v is equal to sine square v divided by v square, c is equal to capital F of v is equal to either 1 when absolute value of v less or equal to alpha, or 0 absolute value of v larger than alpha. And we can draw the diagram that x-axis is v and y-axis is f of v. So from minus alpha to alpha, f of v is equal to 1. So these A, B, C may represent an autocorrelation function of a WSS stochastic process by setting V is equal to tau, or a spectral density function by setting V is equal to omega, or both, which functions capital F of V may represent either or both. Explain your answer. So WSS stochastic process x of t, then autocorrelation function r of tau is real, anti-even, Fourier transform is non-negative, r of tau is less or equal to r of 0. If S of omega is power spectrum of a WSS process of x of t, then they are non-negative. So for first one, subproblem A, capital F of v is equal to e to the power of minus absolute value of v. So we can say that it may represent autocorrelation function of WSS process, because e to the power of minus absolute value of v is even. So first, it is even, and value of minus e to the power of minus absolute value v is less than e to the power of absolute value 0, and the Fourier transform of e to the power of minus absolute value v is equal to 2 alpha divided by alpha square plus omega square. So it shows that it is non-negative. So we can say that it may be represent autocorrelation because it obeys all the properties. And for second one, it also can be power spectrum, because e to the power of minus absolute value omega is larger or equal to 0. And for subproblem B, you see that f of v is equal to sine square v divided by v square. So it can be autocorrelation function of WSS, because sine square of tau divided by tau square is even, and also sine square of tau divided by tau square is less or equal to when tau is going to 0. So sine square of tau divided by tau square is equal to 0. And also we need to show that the Fourier transform is non-negative. So sine of tau divided by tau square, the Fourier transform can be right like this diagram, and it is non-negative. So we can see that it can represent autocorrelation, and it also can represent power spectrum. It can represent spectral density function due to sine square of omega divided by omega square is always larger than 0. And for the third question, f of v is either 0 when absolute value v is less or equal to alpha, or 0 when absolute value v is larger than alpha. So it can be autocorrelation function because 2 times sine alpha omega divided by omega, it can be negative from this equation, and it is possible to be power spectrum due to f of omega is always larger or equal to 0, which is obvious. So this is question 2. Thanks for watching.